Finally, let's talk about multi-class classification. And in particular, we're going to talk about perhaps the simplest but extremely useful approach for doing multi-class classification. It's called one versus all approach. So let's say here's an example of multi-class classification. I give you an image of some object, maybe it's an image of my dog, and I feed it through the classifier to try to predict what object is in that image. So the output Y is the object in the image, which might be a Labrador retriever, a golden retriever, table, monitor, camera, and so on. So that's the prediction task that we're going to do. And it has more than two classes, not just +1 and -1, but may have 1,000 different categories. So how do we solve a problem like this? There are many approaches to doing it. Let's talk about a very simple but super useful approach called one versus all. And I'm going to use the following example where we have three classes: triangles, hearts, and donuts. But of course, you might have many more classes, and I'm using capital C to denote the total number of classes. Capital C in this case is 3, but it could be 10,000 in a different case. And we still have n data points, and now for each data point, we have associated with it not just x1, x2, and so on, but also the category Y, which instead of being just +1, -1, in this case is triangles, hearts, or donuts. And what I'd like to know is, for a particular input, x1, what is the probability that this input corresponds to a triangle, to a heart, or to a donut? Or in the case of the image, whether this input corresponds to a Labrador retriever, golden retriever, or a camera. The one versus all model is extremely simple, and it is exactly what you expect of the words one versus all. Here's what you do. You train a classifier for each category. So for example, you train one that says the +1 category is going to be all the triangles, and the negative category is going to be everything else. In our example, hearts and donuts. And what you're trying to do is learn a classifier that separates most of the triangles from the hearts and the donuts. So in particular, we're going to train a classifier that I'm going to denote by p hat of triangle, which outputs +1 if the input x is more likely to be a triangle than everything else, donut or heart. And then the way that we estimate the probability that an input xi is a triangle is just by saying it's p hat of triangle with y equals +1. So in our picture on the right, here's what our classifier is going to do. It's going to assign score of xi to be greater than 0 on the triangle side, score of xi to be less than 0 on the donuts and heart side, hopefully, which is going to mean that on the triangle side, the probability that y is equal to triangle, given the input xi and the parameters w, is going to be greater than 0.5. And on the other side, the probability that y is equal to triangle, given the input xi and the parameters w, is going to be, hopefully, less than 0.5. So this lets me take a data point and say, is this more likely to be a triangle than a donut or a heart? But that doesn't tell me how to do multi-class classification in general. How do we do multi-class classification in general? And so what we'll do is we'll learn a model for each one of these cases. So it's going to be one versus all for each one of the classes. So we will learn a one versus all that tries to compare triangles against donuts and hearts, which is going to be defined by p hat subtriangle that y equals +1 given xi and w. We're going to learn a model for hearts that tries to separate hearts from triangles and donuts, which is going to be p hat, and we learned on a different data set, so it's going to be sub hearts. That's an ugly heart. I want pretty hearts here. That's slightly prettier, only slightly. The probability that it's +1 given the input xi and the parameters w. And lastly, we have, for a donut, the probability, according to the donut model, of y equals +1 given xi and w. And one last little note is that the W's for each one of these models, or here I'm separating donuts from everything else, the W's for each one of these models is different. You can see by the lines being different. So in the first one is W of triangles, and the second one is W of hearts, and then the last one is W of donuts. So we train this one versus all models, and what we output as a prediction, we just say whatever class has the highest probability wins. So in other words, if the probability that the input is a heart against everything else is higher than the input is a triangle, higher than the input is a donut, you say that the class is heart. More explicitly, in multi-class classification, we're going to train a model to ask for each class what's the probability that it wins against everything else, the probability of y equals 1 given x, and you estimate one of those for each class. And then when we're given a particular input xi, for example, this image of my dog, what we're going to do is compute the probability that every class estimates and output the maximum. And I just written out here the kind of natural algorithm. So we start with the maximum probability being 0 and y hat being this non-category 0. And we go class by class and ask, is the probability that y equals 1 according to the model for this class, the model for Labrador Retriever, the model for Golden Retriever, the model for camera, is that higher than the max probability I've seen so far? If it's higher, that means that class looks like it's winning. So we say that the y hat is whatever this class is, and we update the maximum probability to be the probability according to this class. And as I iterate over each one of these, the maximum is going to win. So this is just kind of an algorithmic statement for exactly what you'd expect. You check how each model believes, whether it believes it's a dog, a Labrador Retriever, a Golden Retriever, a camera, what the probabilities are, and you just output the object that has the highest probability. And with that simple algorithm, we now have a multi-class classification system by using a number of these binary classifiers.